Hello everyone, my name is Andrew McGrath. Today I'll be presenting the optimizations I made to the VM translator for my CS Capstone project. The areas of focus I will talk about are attempting to reduce the redundant compactable instructions, attempting to reduce the program size by using subroutine calls, and reducing the program size with the process of dead code removal. Attempting to reduce instructions. Within the code generator of the VM translator, I had identified a few instructions that I felt were redundant, could be assigned better, could use multiple assignment, so on and so forth, and attempt to make fewer instructions. While initially I believed this had worked, while checking out the CPU profiler running the hack, the clock cycles had been reduced. But I decided to do some sanity checks with other hack files with known behavior and realized I had reduced instruction count but broken functionality. So these modifications need to be removed. I then shifted my focus to reducing size. So instead of trying to make the program run faster, I decided to try to get the most bang for my buck and compress it down as small as I could. To do this, I wrote subroutines for pushd and popd. Subroutines write the ASM for a functionality once, and whenever that block is needed, it's called back to. Analyzing the code generator of the VM translator, there was a great number of calls to pushd and popd. Therefore, I created subroutines to call these functions in an attempt to save space. More on how subroutines work. Subroutines should be used to reduce the creation of very large functionalities, such as return. Return is very large. You don't want to have to write it every time it gets called. Instead, you want to call back to it being written once and use that over and over to save space. However, pushd and popd are not very large. In fact, they're only 4 and 3 instructions each. On the left is the code for popd, which is 3 instructions. On the right is the necessary code to call a subroutine. As you can see, there's a bit of a problem because a subroutine call is more than twice what it takes to use popd normally. So while the subroutines I wrote did work as intended, it had the opposite effect of what I was looking for. The instruction count for pushd and popd were replaced with subroutine calls that more than doubled each of them. This explosively wasted my memory and was the opposite of what I was intending to do in the first place. So I had to not use those subroutine calls. I then removed on to dead code removal. Functions that are written but are never called during or not used during execution. This makes them dead and a waste of valuable space. I optimized the VM translator to identify these dead functions in our VM code and remove them before the translation process. The process of identifying dead codes begins with building a map of declared functions and the functions that are calling them. If A was called by B and C, and B was called by A, so on and so forth. Functions that are never called by anyone are therefore dead and can be removed. To further optimize, I looped through the remaining live functions and reduced their calls to every dead function that had been calling upon them. This would kill functions that were being kept alive by dead functions. I would also then add those killed functions to the dead list and can further remove other dead functions that were dependent upon those. This is an example of that process. Function math.fake is called by no one and has a call count of 0. The function math.faker was only being called by math.fake. Therefore, with math.fake dead, you can also kill math.faker, and it's been flagged as a dead function. And if anything was being called by it, those counts are also reduced, so on and so forth, until you get a comparable list of dead functions. Those functions were then removed and not translated. As a result, the size of the S2020 hack file was reduced by 5%. Other files I tested with had much better reduction. That's because the size of reduction depends on the amount of dead code a program actually has. So the more dead code, the better. Some of the test files I used weren't using any of the OS systems and therefore were reduced by 15, 10%. Really good numbers. However, even if it is just 5%, any reduction could be the difference between fitting in the CPU or not fitting in the CPU. These were the optimizations I attempted and did make to the VM translator. Thank you for watching. Have a good day.